This is the first talk for the conference about Spring. Applause. Yay. Yay. Spring is everywhere. Okay, let's be honest. Who of you code for money and do it with Spring? Okay, lovely. So you came to the right place, cool. I guess. I'm on Jakarta E guy. I don't like Spring, sorry. But everybody knows that the Spring is the framework. I have nothing else to say about it, and I'm really happy that today Sebastien Deleuze from Lyon, wonderful city of Lyon, has come to make a talk about runtime efficiency, and he is the guy from the source who actually makes this efficiency. So I'm really happy and excited to present you Sebastien. Please welcome. Applause, and the stage is yours.
Okay, thank you. I'm Sebastien Deleuze. I'm working in the Spring Framework team as a Spring Framework core committer. So my day job is to fix issues, bugs, implement features on the Spring Framework and in the wider Spring portfolio. You can find my social media account on seb.deleuze.fr, Mastodon, LinkedIn, and Blue Sky. Today we are going to talk about runtime efficiency with Spring, but I'm not only working on that. So if after the talk you want to talk about Kotlin, I have introduced Kotlin support in Spring, so I may provide information to you. I'm also working currently on bringing null safety on a Spring Framework and the wider Spring Portfolio API with gSpecify. I recently merged what is probably the biggest commit ever on Spring Framework to migrate to gSpecify annotation to provide null safe API, so it looked like people are excited about that. I'm also recently, like just yesterday, I merged the Jackson free support. This one was split into multiple commits. And I'm also working on the GraalVM support for Spring. I work on that with the wider Spring team. But today, we are going to focus on optimizing your Spring Boot application with a regular GVM, with two technologies, CDS and Project Leyden, and we are going to go more into the detail of those technologies. But first, let's talk about why do we care about runtime efficiency. Typically, when I talk with open source user, customer, it's about getting cheaper hosting. We all want to reduce the cost of the hosting of our Java and Spring application, either in the cloud and premise. Usually, this is done by using smaller instances, less CPU, less memory. And typically, this goes well with improving the sustainability of our workloads, because usually using cheaper server is basically consuming less resources. And also, we are in a world where the Java workloads, we deploy them as containers. And with containers, the Java ecosystem is a bit challenged by other technologies like Go, Rust, and other technologies that allow pretty good efficiency. So this is also why we want to optimize the efficiency of our Java workloads. Today, we are going to explore three variants. First, we are going to talk about CDS, class data sharing, which is a pretty old technology, but it has been recently more and more used. And then we are going to explore AOT cache, which has been introduced by Project Leyden, which intends to provide more efficiency with a regular GVM. This is available in Java 24, so it's available on production right now. And after that, we are going to see AOT cache with experimental Project Leyden features, profiling, and code compilation. And this part is experimental, but is progressing pretty fast. We are going to talk about various ways of doing training runs. So training runs, the principle is that you are going to start your Spring application, potentially not entirely, but just the first part of the startup, in order to create a cache that will typically contain the classes that will be loaded by your application. And the goal here is to make the deployment run, typically on production, start faster in order to be able to deploy your workloads on cheaper servers, even scale to 0 if the startup is super fast, consume less memory. So this is another way to reduce the cost of our hosting, and also to get a faster warmup. We all know that it takes some time for a GVM to be warm, to provide the optimal peak performance. And so here the goal is to get to the peak performance super fast. So we are going to start with optimizing our Spring Boot application with CDS. So the requirement for Spring Boot plus CDS is Java 17, because this is the baseline for Spring Boot 4, Spring Boot 3, excuse me. And we are going to require Spring Boot 3.3 because it provides a new feature that I'm going to explain just after. You will see that sometimes in my demo, I'm going to use java-d spring context exit equals on refresh. The goal of this flag that you can use on any Spring Boot application with Spring Boot 3.2 plus is to basically begin to start your Spring application, but not doing the whole Spring lifecycle. So the goal here is to instantiate the non-lazy singletons, invoked after property set, which is the initializing bin method, and then exit. The goal here is to only get the application loading the classes in order to allow CDS or AOT cache basically be aware of the classes that are concretely used by your application to cache them, but not doing the rest, like contact, remote services, etc. So we cut the startup at the middle just to get enough information to get an efficient cache. The second feature that we are going to use, it's a teeny feature, but I really like it. It's a way for Spring Boot executable jar that you typically build with Maven or Gradle to self-extract itself into an efficient layout. Because if you are on production and you are not using Buildpacks or you are doing custom Docker files, if you are just doing java-jar, the executable jar, you are not using the most efficient way to run Spring Boot application on production. You are consuming more memory, and the startup is longer than it could be. So you can extract it yourself using unzip or jar, etc. But it's better to use this provided command that requires no other tooling. So in your container, you don't need unzip or other tooling. You just do java-jar mod equals tools, the -jar, the name of your jar, extract, and then it will create a directory with the libraries that are directly in a directory, and then a tiny jar that will only contain the application classes and the class path defined in a manifest file. And if you start with this tiny jar that will use the libraries in the libs, your application will start faster. It will consume less memory, even if you are not using CDS or AOT cache. So I recommend, if you are not using Buildpacks, which is Spring Boot default way to create containers, I advise you to use this executable jar self-extracting command for any production deployment. So we are going to see a demonstration of CDS using the special flag that I show and this extract command. The goal here is to start faster our application and consume less memory. So we are going to use Spring Pet Clinic, which is a typical example. Maybe one day I will build a more recent example, but we are going to use this one. We are using Java 21. We could use Java 17 as well, but here 21 because this is the latest LTS. We build Spring Pet Clinic in order to create the executable jar. And then we are going to we are going to run it with the executable jar just to show you the baseline, okay? So if I directly run the executable jar, my application starts in 3.2 seconds. This is our baseline. Then we are going to use the extract command in order to extract our executable jar into an efficient layout on file system, no nested jar anymore, etc., just plain file layout. If we check the directory structure, you will see that we have a tiny jar and then a lib directory with all the dependencies. So it's pretty simple. Again, you can do it with unzip, but there is a few specific things in the way how it is architectured that make it CDS and AOT cache friendly. OK, now we are going to create the cache using the Spring context exit equal on refresh, and we add a CDS parameter to say create the cache when the application exits. So the application begins to start, automatically exit. CDS is creating the jar, so we will see that we have a .gsa file that will contain the cache, that will speed up the loading of the class, etc. And then we are going to start again our application using the cache that CDS has created, using this shared RChef file equals Spring Pet Clinic GSA. And then you can see that our application starts twice faster with not much effort. We had no involved things to do. It's pretty simple. So I'm going to share various data points in this presentation. So here you can see that if we take the executable jar startup time as a baseline, just unpacking it, zero effort, zero CDS, nothing, it already starts faster, okay? And if you are using CDS, that can be potentially combined with another optimization that I will detail a bit after Spring IoT. Basically, you start your application twice faster, and this is on local machine, but also in the cloud. I have been able to verify it in various environments. Of course, it depends on your application. It may be faster, slower, but the key point is that you have an extra boost, a significant extra boost with very low constraints. On memory side, we see lower memory consumption, not at the level that we see with GraalVM native images, but still interesting to get 20% reduction. It's more memory available for your heap, and so you will be able to get better performance, or you will be able to use smaller instances. A lot of people ask me why CDS is not used more, because it's available since Java 9, I think. It's pretty old technology. So the first reason is that CDS has been maturing a lot since Java 9, since introduction, and in Java 17 and Java 21, it's much, much better. Also, initially, it was mostly designed to share multiple Java applications running on a single instance, but now with container, we have one Java instance per container. And so the technology has evolved to adapt to modern constraints. The other reason is that there is a lot of CDS rules to follow in order to make it effective. If you are not following those rules, your application will start, but you will see no gain. And so a lot of people, before we provide this support, try to use CDS, see no gain, okay, we stop using it. So the first rules of the game between the training and the deployment run, you need to use the same GVM on the same operating system with the same patch version. You need to take care about the class path, and this is why we created this efficient extracted format that follows the CDS constraints. The class path must be specified as a list of jar, no directories, no star wildcard, no nested jar. So if you are directly using a Spring Boot executable jar, it will not work because it is a nested jar. And also the deployment class path must be a superset of the training run one. So you may have the possibility to add more library during the deployment run compared to the training run, but it must be a superset and the new libraries must be added at the end. Also, there is some simple things that could break CDS assumption, and this is why this is a good fit to put everything, I think, in a container to basically be in control of those constraints. If you just copy the files between the training run and the deployment run, it will not work, simply because the copy will basically modify the timestamp of the jar, and CDS requires the timestamp to be the same because this is a fast way to check the files have not been modified. SHA-1 computation will be too slow. And so if you copy the files, take care about using the small argument to keep the timestamp, otherwise CDS assumption broken. And lastly, the training run is not obvious. When should we run this training run? How should we run it? It may try to connect to remote services. So I think this is for those reasons that CDS has not been used very widely before today. So the main side effect you should take in account is that potentially the database, your application may try to reach the database because it happened pretty early in the Spring lifecycle. So we try to stop the Spring lifecycle pretty early when we use the special exit flag, but you may have some database connection. So this is why we have documented on this page how you should configure your database to avoid early database connection. And even without CDS, that could be a best practice that your application do not try to contact your database when it's starting. For GPA, for example, you can see that it's about configuring explicitly the dialect. Here, this is PostgreSQL. And also disabling the JDBC metadata at Hibernate level. And of course, you should not try to initialize your database during the startup because otherwise, of course, a connection will be made. And you can just define that by default, and you won't have any side effect for most CDS use case. But there's still a lot of integration. So we have tried to provide a CDS support in Buildpacks, which is the default way to create container images with Spring Boot, to have everything included. Like if you are enabling a special flag that I will show in my demo, you just run Maven Spring Boot build image or Gradle boot build image, and Buildpack and Spring Boot will automatically do the training run, create the CDS cache, put it in a container image, potentially with the Spring IoT optimization, and use automatically the CDS optimization when you run your container. And I think that's pretty neat. I'm going to show you that in a demo. So here we are going to first build our container with Buildpack without CDS enabled, just to have a baseline in terms of startup time. So yeah, Maven boot build image. We are basically building our container image automatically. OK, it has been built. We are going to run it with Docker run to have our baseline for the startup time. And our application starts in around 3 seconds. OK? Now, to show you how it is easy, I'm just going to enable CDS with a Buildpack flag that we set at the level of the Spring Boot Maven plugin. Just CDS enabled equals true. OK? And then I'm going to rebuild exactly the same command, Spring Boot build image. And here, Buildpack will automatically perform the training run, put the file, the cache file in the container image, and configure everything that when we run our container, the Java command will use the cache that has been created. So the cache file is within the container, so you can deploy it on any kind of run platform. It's a bit longer because there is a training run. And we are going to run again this container image that is self-contained. And we can see that our application starts in 1.8 seconds, which is much, much faster. And again, not a lot of constraints. It's pretty easy. So the benefits are a bit lower than GraalVM native images, but the pain is much lower, and it's still regular Java, so you don't have any compatibility issues, etc. So that's CDS, that's the old technology. Let's see what we can do with Java 24 and IoT cache. So before going more in detail, IoT is used in various contexts for various different things. When I see IoT cache, it's the CDS successor that has been developed as part of Project Leyden and that has begun to be available as part of Java 24. Okay? IoT cache, JVM technology, successor of CDS. When we are talking about Spring IoT, I don't go too much into the detail of Spring IoT in this talk. It's mostly CDS and IoT cache focused. Spring IoT is a feature that we have developed primarily for the GraalVM native image support, so it's mandatory for GraalVM support. It's basically compute a static version of your application context to speed up the startup time and provide native compatibility. And you can optionally use it on the GVM, but it introduces some side effects and constraints, like you need to pre-compute the configuration file for specific Spring profiles. So this is why with the open source stuff, I advise you to use primarily, initially, just IoT cache, and then you see if Spring IoT could be a good fit. IoT cache has less constraints. So IoT cache is coming from Project Leyden. It has been integrated into Java 24, recently released, the last version of Java available, with this JEP 4.8.3. Ahead of time, class loading and linking. And this is mostly an improvement of what CDS provides. But this is the beginning of the story. Java 24 is the first version to provide IoT cache, but IoT cache will get improved in Java 25, 26, 27. So I think this is a good investment for the future. The requirements for IoT cache are Java 24, because this is the first version that provides it, and still Spring Boot 3.3+. We don't provide Buildpacks support, so here I'm going to show the demo with just the manual version that I showed previously with CDS. So let's see what changed compared to CDS. We are going to do the same thing. We are going to start our Spring Boot application with IoT cache instead of CDS. So it begins the same way, just we use Java 24 instead of 17 or 21. We then build our pet clinic application. Nothing changed. We are going to use the extract command that we use because it's CDS and IoT cache friendly. If you try to do stuff manually, it won't work, believe me. So here we have an IoT cache friendly layout of our Spring Boot application. And then we are going to use the record mode of AOT cache, which is not going to create directly the cache, but it's going to create a kind of profile of the classes that are used, etc. So it's kind of intermediate step that will create an AOT conf file that I'm going to show you. Okay, so pretty small AOT conf file, and then with this file, as a second step, I'm going to use the AOT mode create in order to create the cache. So instead of CDS that does that in one step, here, almost the same in two steps. But interestingly, you could potentially just do the first step on production and then create the cache that is taking more time and more energy on your CI, etc. So more flexible. So the .iot file is the equivalent of the GSA file that we had previously. And if we start our Spring Pet Clinic application with this command, so we just remove the other parameter and we just keep the name of the cache. So pretty similar to CDS, you will see that we start our application in 1.3, 1.4 seconds, which is faster than CDS. The difference is not huge, but again, this is the beginning of the story. AOT cache in Java 24 is the first incarnation, and the difference between CDS and AOT cache is going to be bigger and bigger. But still, it's still a boost. We are now at 2.2x faster startup time compared to executable jar with the same low constraints. In terms of memory consumption, the same. I hope that AOT cache will provide more memory reduction benefits in the future, but right now you can expect the same thing than CDS, 20% reduction after startup and after GC to get things easy to compare. Yeah, hopefully that will provide more benefits in the future. So this is what you can use today in production. Of course, it requires a bit of integration because you need to do this training run, etc. But again, this is actionable even on big historical legacy projects, even on a recent one. But if you just migrate to Spring Boot 3.3+, you can use that even in big projects. And I would say that the benefits will be even bigger on big projects with a lot of dependencies because that will speed up the loading of all your classes. It also caches the class path checks, etc. So it can really be pretty nice on big application deployed on the cloud on small machines. But more is coming. Like I said, AOT cache in Java 24 is just the beginning of the story. So the upcoming features that are coming, there is this JEP 5.1.5, ahead of time method profiling. This one may arrive short middle term. It's a way to get the profiling data from your production. So here you will typically get those profiling data directly for your production deployments in order to warm up your GVM faster. Okay. The second improvement is JEP 5.1.4, ahead of time command line ergonomics. This one is to allow to create the cache with a single command. You have seen that with CDS, one command was required to create the cache. AOT cache, two commands, records and create. This JEP is just a quick shortcut to be able to create the cache with one command. And the last one, which may happen more long-term because it's more involved, it's more experimental, it's ahead of time code compilation. It's about taking the native code that the JIT has compiled on production and directly use it in your cache in order to speed up the startup time and warm up your GVM much faster. We are going to see a demo of that, and here I just take a bit of time to say that here we are not going to use the exit flag and doing stuff like that. Here I'm going to do a demo of what I would expect you to deploy in production, like the profiling data, the code compilation required to have a realistic workload that is applied to your application. And so the easiest way to do that is to basically generate the AOT conf file that will profile your application on production. Some people try to do that with tests. Disclaimer, it does not work because the class path is not the same and various other constraints. So don't try to compute CDS or AOT cache based on your test. I understand that that could be attractive, but that does not work at all. Okay. So I think the two options are really what I showed previously. you are doing in a kind of automated way, even like Buildpacks, with no connection with your remote services. You try to compute the CDS or IoT cache just for startup time and memory consumption. Or what I'm going to show here, you try to deploy it on production to get the profiling data and the code compilation directly from production. So here I'm going to use a special build of Project Leyden. So this is the experimental one, not available into a regular Java version. I'm going to build my pet clinic application like I did previously. OK. I'm still going to use the extract command because, again, it is IoT cache and CDS friendly. So I'm using this optimal layout that will allow to take advantage of the IoT cache optimization. OK. And now I'm going to do things a bit differently. So I'm trying to start my application in record mode, but here, no exit flag. So I will keep it running to simulate a production application. And to simulate the production workload, I'm going to use a little tool that I like a lot, OR, in order to apply a fake workload. And here you will see that your application is going to warm up progressively. So we see that the throughput of the requests are improving because our GVM is getting warmer. In practice, you will just apply some production workload, so you don't have to apply this kind of thing, except if you want to do it on staging. And so here, I have recorded a profile that includes some information from the production, that includes the profile and the IoT code compilation. Then I'm going to use the create mode in order to create my cache. But here, I'm taking benefits of both IoT profiling and native code compilation. OK, so here the cache is a bit bigger, but it will be potentially directly present into the production. And so I'm going to start my application using this .iot cache. And we are going to see a few interesting things. So same, I'm remove the over parameter. I'm just using the cache that has been created. OK, and now I see that I'm able to start my Spring application in 0.9 seconds, so much, much faster. And I think that's pretty cool. And even more interesting, the warm-up of my application is almost instant because my Spring Boot application has been warmed up on IoT side. And so when I deploy it, it provides the peak performance almost immediately. So if we see related data points, we see that with this experimental version of IoT cache that basically will be available in a few months, year, not sure, we are able to start our application 4 times faster, again, without that much constraints, if I do the integration of that with my production. So that's basically twice faster than the current incarnation of IoT cache. And even more interesting, and I think this is the most interesting diagram of this presentation, this is basically showing the throughput of my Spring application after the startup. The blue line is the baseline. The blue line is a regular JIT that we all know. And here, I'm just exercising a single endpoint, so it just takes 30 seconds to warming up. But in practice, that may take much more time on a more complex application. And you can compare it with the red line, which is just with IoT profiling, okay, from the production. And we can see that it's able to warm up your GVM much faster. And this one could arrive, could be available short, middle term. So that's interesting to see. And if I'm using the code compilation that has been done on production, here the warm-up is even faster, but this one will take a bit more time to be available in the GA Java version. You can see that there is a difference of peak performance between the blue, red, and yellow line. It's a kind of limitation, a bug, that will be fixed by the Java platform team, hopefully. In theory, when this will become available in a regular Java version, the peak performance should be the same. It should only provide benefits to have faster warm-up. And faster warm-up is pretty cool because we can potentially scale our application to 0 and just start them when basically some workload is coming, kind of serverless mode. It can allow us to scale from 1 to 2, 3, 4, 5 much faster and be able to absorb a lot of workload. So imagine that you have a website that takes a huge peak of workload. It will allow to add instances and have them effective super fast. And that's pretty cool to be able to do that with a regular GVM in the future. So if we want to compare the GraalVM, Project CRaC, and AOT Cache, I have not put CDS because AOT Cache is the CDS successor, so I want to simplify a bit. GraalVM native, I like it. I mean, I have been spending so much energy and time to provide Spring support for GraalVM native images. It's pretty cool. It allows to have instant startup, so dozens of milliseconds, much faster than what we have seen today. Instant warm-up, super cool. For peak throughput, if you just use the community edition of GraalVM, you get lower peak throughput because there is no JIT involved and the optimization done are less effective. So the peak performance can be significantly lower. It's possible to do a training run to get closer to the JIT peak performance, but that involves some pain using GraalVM, so not the open source version. You need to do a training run plus the other native image constraints. So in practice, what I see is that almost nobody is doing training run with GraalVM because this is too complicated. Memory consumption is reduced, so that's pretty cool. But there are pain points that limit GraalVM adoption. And again, GraalVM native image is a good technology, but it's maybe not for every project, not for everybody. Compilation is very slow, and there is compatibility issues because GraalVM requires explicit configuration of reflection, proxies, resources. And so in practice, you need to have native support for the libraries that you are using. Spring is going to automatically create the right reachability metadata, but still, you will likely have to do some extra configuration to get native support and combine with the slow feedback loop because very long compilation plus manual hints, the developer experience is not crazy good. And I think this is what is currently limiting GraalVM native image adoption, but still interesting and useful for some projects. And that's a good technology. Project CRaC, I think, yeah, it has stronger issues. So initially, Project CRaC looked like the best of the two worlds. It provides instant startup like GraalVM, but it's on the GVM. So you say, yeah, no problem. Why do you need AOT cache? The reason is that when you are deploying your application in production with CRaC, you are not starting it. You are going to restore it, basically, to resume its execution. And so there is a lot of issues that are coming from open file handle and sockets that need to be closed after the training run, reopen after. Some libraries do not provide the right APIs for that. So in practice, it's very hard to have the right compatibility. It's Linux only. So if you are on Windows or Mac, you need to use Docker. And the most important issue, CRaC is a bit hardcore. It's going to serialize your GVM memory on disk, and so including your secrets, your passwords, etc. So you can't ship the cache file of CRaC usually with your container because that will be a terrible security issue, and it limits its adoption. So personally, it's not an official Spring advice, just my advice. I do not really recommend CRaC on production. I would either use GraalVM if you are OK to swallow that pill and accept the constraints, or use AOT cache to optimize. And I think AOT cache got some inspiration from CRaC, but in a more first-class way. It's not just serializing the memory representation. So AOT cache 2x to 4x faster, fast warm-up with the training run, when basically it will be supported. Memory consumption is slightly reduced, fast compilation, and there is some side effect, but very few, like this early database connection that can be fixed by customizing the configuration of your Spring Boot application, or just if you are using the production deployment that I showed, basically you don't care because your training run is your production run, so there is no really side effect. There is just a work to integrate AOT cache with your production. And before stopping, a few more things about the future. First, IoT cache is going to be combined with various other improvements of the Java platform that are coming, and that are coming pretty aggressively, because I'm not sure if you have seen, that's pretty recent. Compact object headers, that is a way to reduce the memory consumption of the JVM, is going to ship in Java 25 before the end of the year without an experimental flag. So there is other improvement like stable values and other JEP. So IoT cache is going to be combined with other Java platform improvements, and together, I think that will provide a pretty nice efficiency improvement. There is also other technologies that I do not cover in detail today, but in Java 24, one of the main painful issues with virtual threads, the thread pinning issue that was preventing wider adoption, has been fixed. That means that in the next LTS 25, Java 25, I think virtual thread will be ready for wider adoption, and we will be able to enable in most of our projects. So that's pretty cool, and that's a good combination with IoT cache, even if the two are not directly related. And if you follow a bit the work that is done on experimental side on Project Leyden, there is some very interesting discussion. For example, here we have Alexei Chiplev, who is basically merging an IoT-only mode that do not perform any JIT during the runtime and only rely on the IoT information of the profile and the native code. So it's a bit like if we want to make the JVM work like native. Of course, it will be slower because there is less impressive optimization, but there is also lower memory consumption because you don't have to activate all the JIT, etc. So I don't know if that makes sense or not, but what this discussion show is that Project Leyden may allow to make the JVM more flexible. You will decide how much basically infrastructure you chip to do the JIT optimization, how much optimization you are doing ahead of time, and so potentially you will be able to configure that and get the behavior that fits with your needs. So again, maybe that's just an experimentation, but I think that's pretty interesting to see that they are exploring various options. And lastly, and that will be a bit of a teaser, Spring IoT, which is not very detailed in that presentation, we are going to announce next week at Spring I/O some very interesting improvement in Spring IoT that will bring significantly better benefits with Spring Boot 4. I can't talk about that because that will be announced next week, but follow the upcoming announcement. And Spring IoT and IoT cache combines together very well. And so if you combine both, you should be able to have very interesting benefits with Spring Boot 4, which we will release in November this year. Thank you a lot. You can go to seb.deleuze.fr if you want to see my social media, etc. And thanks for your attention.